Hello students, welcome to my channel projectile. I have brought this question. It was asked, I think in 2024, ITJ Mains, right? Advanced, sorry. A ball is thrown from a location x naught, y naught, 0, location from a horizontal ground with a velocity v naught at an angle theta naught from positive x direction. Ball is hit by a stone which is thrown from x1, y1, L comma 0, right? Look here, it is y coordinate is 0 in both the at both the points, means both the points are at the same level. Look here, x naught, y naught is 0 comma 0, x1, y1 is L comma 0. Y coordinate is 0, it means both are at the same level, at the same ground, right? At an angle 180 minus theta 1. Let's make this diagram. Look here, the first one is from x naught, y naught, or you can say it says 0 comma 0. The ball is projected at an angle, this is a theta naught, right, with a velocity v naught, good, and the it is hit by a stone which is thrown from L comma 0, right, at the same level, that is at an angle 180 minus theta 1. From positive axis 180 minus theta 1, you can say if this would be theta 1, then it is 180 minus theta 1, right? In this way I am saying you that if this one is theta, then this angle would be the 180 minus theta 1 from positive x-axis. Now look here, from x direction with a suitable velocity, let that velocity is v1, right? We do not know what the velocity is. For a fixed v0, 45 degree, 45 degree, both the angles are 45, 45 degree, then the stone hits the ball in time t1, right? And when it is 60 degree and 30 degree, the two angles, the stone hit the ball at time t2, then you have to find out the t1 upon t2 whole square. Now dear student, the basic condition that what is the basic condition that the stone hits the ball? Let stone hit ball goes here and stone hits the ball here. Either you apply both traverse equal vertical distance or horizontal distance. This horizontal distance is traveled by the first ball and this is traveled by the second ball, and their sum is equal to L, right? Both the ball and stone, both are thrown at an angle theta naught and theta 1 respectively from the same level, right? If they are projected from the same level, then no doubt they should reach at the same time to a vertical height where they meet to each other, where they collide to each other. What I used to say, what I am saying that let at this point both the stone hits the ball or projectile, right? It means ball has traveled, in the meantime ball has traveled this much of horizontal distance and this much of vertical distance, right? And in the meantime this stone has traveled this much of horizontal distance and this much of vertical distance, because in the meantime both are projected simultaneously. In the meantime they travel the same vertical height, right? This one travels this much horizontal distance and this much horizontal distance is traveled by the stone. Now dear student, in the same time they travel the same vertical height in order to collide, right, in order to hit the ball by stone. So it means the basic concept you will apply that they possess the same vertical velocity, right? Their initial vertical velocity should be same. Only then they will travel the equal vertical height in the same time. So the first condition is a 45 degree. So I'm applying, it's a vertical component will be v naught cos 45, and that is equal to, it's a vertical component for 45 degree is a V1 cos 45. Dear student, this would be cancelled, so V naught equal to V1. Now look here, when it is a 60-30, if this is thrown as 60 degree and this is thrown as 30 degree, then its a vertical component will be V naught, vertical component should be sine, yet there would be no change, but this would cancel. Now look here, now they are thrown as 60 degree and 30 degree. In that case, the vertical component of it will be V naught sine 60, and its a vertical component will be V1 sine 30. Or you can say V naught root 3 by 2, that is V1 into 1 by 2, 2 would be cancelled, so root 3 V naught is equal to V1, right? This is, in this condition when stone hits, it takes time t1, and in this condition when stone hits the ball or projectile, it takes time t2. Now dear student, it's a very simple concept to apply the relative velocity, right? It's a very simple concept to apply the relative velocity in case of collision. How? Look here, let it is a and this is a B, right? At the A, here is the observer, right? So velocity of B with respect to A, you say velocity of B with respect to A is equal to VB minus VA, right? Why is easy to use the relative motion? I'm telling you, VBA is equal to VB minus VA. It means velocity of B with respect to A means the velocity of B observed by A when it is at rest. If A is at rest, it means it has to travel that whole much distance. But case is that you should know the velocity of B with respect to A. Just I have said that velocity of B with respect to A means what is the velocity of B when A is at rest. If you can find out the VBA, then where the B will hit the A with velocity VBA, B has to travel this whole much distance, and the things become very simple. So in this case, in the first case, time will be T1 is equal to distance upon velocity. Distance is that much, L upon velocity, horizontal component, because if A is at rest, if you are considering the velocity, relative velocity of B with respect to A, it means A is at rest. So B has to travel this whole distance, this L distance, in order to hit the A with velocity VBA. So this is the T1 is equal to the time in which stone hits the ball. The T1 is equal to distance upon velocity of B with respect to A, the horizontal component of velocity of B with respect to A, right? So velocity of B with respect to A, that is both the velocities are facing in this way, they are opposite to each other. So in the relative velocity, if the two velocities are facing to each other, opposite to each other, then what we do, we add these two velocities. So it will be, dear student, this is a V naught cos theta naught plus V1 cos theta 1. Now V naught in the case of 45, what is theta naught is, just I'm erasing this one here, so I will get the space, just a matter of little time only. Now dear student, in the case of 45, we have find out V naught is equal to V1, right? So it is T1 is equal to L upon, this is a V naught and this is a 45. Cos 45. So cos 45 is a 1 by root 2. So V naught by root 2 plus V naught by root 2. So it is a 2 V naught by root 2. You can say T1 is equal to L upon root 2 V naught. Now again, dear student, look here. T2. Let's talk about the T2. T2 is the case. T2 the time taken when this is a case of 60 degree and 30 degree, then time is t2. Again I am repeating, t2 is equal to horizontal distance upon horizontal relative velocity of b with respect to a, what is going to be, this is a v naught cos 60, right? It's a v naught 60 degree, v naught cos 60 plus v1 cos 30. Now dear student, look here. In this case, we have find the relation between v naught and v1, or v1 is equal to root 3 v naught. So it is t2 is equal to L upon v naught cos 60 is a what? 1 by 2 plus v1 is a root 3 v naught and cos 30 is a root 3 by 2. So it turns out to be t2 is equal to L upon, look here, this is 1 by 2, v naught by 2, 3 v naught by 2. So 2 would be the LCM. This is a v naught by 2 plus 3 v naught by 2. So it's a 2 is the LCM, 4 v naught by 2. This is 2 L upon 2 v naught. In the first case, we have got T1 is equal to L upon root 2 v naught. In the second case, T2 is equal to L upon 2 v naught. So T1 upon T2, that is equal to L upon root 2 v naught divided by L upon 2 v naught. So it is LL would be cancelled, 2 v naught upon root 2 v naught. V naught would be cancelled, this is root 2. So T1 upon T2 whole square. The question was asking T1 upon T2 whole square, and that works out to be the 2. This is the answer. Dear student, I tried my best to let you understand the problem. If there is a problem, there is some confusion regarding this solution that I have given, so please comment, and least but not last is my special request, a request from deep and sincere my heart. Please and please like, share and subscribe, and stay tuned for the next video. Thank you.